I am Galos, and for today's video, I'm going to talk about stress transformation using Moore's circle. We all know that analyzing solid mechanic problems in three-dimensional can be really hard to work and it can get very complicated. Fortunately, in a lot of cases, there are some simplifications we can reduce to three-dimensional problems to a two-dimensional one, making it much easier to solve. And now, let's start by reminding ourselves about stress element. Stress element is a useful way of describing the stress acting at a single point of the body. The normal stress and the shear stress are shown on the four faces of the element. And now, we are going to tackle about our main topic, which is about Moore's circle. Moore's circle is a graphical method for easily determining the normal and shear stress for different orientation of our stress element without having to use the stress transformation equation. This is how it looks like a plotted Moore's circle. At this time, I'm going to teach to you how to plot Moore's circle. The first thing we need to do is to draw a horizontal line and our vertical line, which is our tau and sigma, or the shear and normal stress. Second is that plot our x and y coordinates. Third, connect our x and y coordinates with a diagonal line. Fourth is that find its center. Third, connect our x and y coordinates with a rounded circle. Next is that find its radius, which is equal to our tau max. And lastly, find our sigma 1 and sigma 2. That's how we're going to plot our Moore's circle. This is how it looks like a three-dimensional stress element. We have three principal stresses, which by conventions are numbered from largest to smallest. Moore's circle in three dimensions is made up of three different circles drawn as shown here. Let's try this example. We have a figure of stress element which has a given of 140 MPa, 25 MPa, and 42 MPa. The question is, for the given state of stress, determine A, the orientation of the planes of maximum in-plane shearing stress, and B, the corresponding normal stress. Let's solve this using Moore's equation, Moore's circle. The first thing we need to do is to have a given which is equals to sigma x equals to 25 MPa, sigma y which is 140 MPa, and tau xy which is equal to negative 42 MPa. The first solution we need to do is to find its sigma average. Sigma average is equals to 1/2 sigma x plus sigma y. By inputting its value, we get sigma average which is equals to 82.5 MPa. At this time, this is the Moore's circle of the questions above or the questions earlier. But before that, I will explain to you kung yun saan ako pagkuha. First is that First is that I'm going to plot my x coordinates, which is 25 and 42. This 25 and 42. Second is that I'm going to plot my y coordinate, which is 140, this one, 140, and negative 42 in y. As I get my x and y, I will connect it with a diagonal lines there. Since I have an f, let's say that f1 and f2. The third thing we do is to find its center, this one, center. By finding the center, the equation is this one, 140, minus this one, which is 25, all over 2, which is equals to 57.5. This is the value of this one from F1 to F2 is 57.5. Then, by finding its center, we divide 57.5 by 2 to get the center. 57.5 divided by 2, which is equals to 28.75. This one, 28.75 from this one, and also from F to C is 28.75. The next thing we do is to find its radius. By finding its radius, 28.75 squared plus the height, which is from F to X, which is 42. By inputting it in our radius formula, we get a radius of 50.9, which is tau max is equals to radius, this one, D. That is the 50.9. These broken lines here. Getting the value of our A and our B. A is also equal to sigma 1. To get our sigma 1, we need to add this from C to this is 28.75. Then add this F, which is 25, and our radius. So Q1 is equals to 104.65 MPa. So the value of this one from the is 104.65 MPa. Then, by getting our sigma 2, which is our B, we need to add 28.75 plus 25, but negative radius minus radius. So our sigma 2 is 2.85 MPa. By getting this tangent A, we need the equation of our tangent A is f of x over f of c. The value of our f of x is 42. This one, from f of x to this f to x. And our value of f of c, which is equals to 28.75. By calculating it, we get tangent A, which is equals to 141.46. Then, by calculating it by eliminating the tangent, we need to solve its inverse tangent. So we get A is equals to 55.6 degrees. Then, we solve for theta B. Theta B is equals to 1/2 of A, which is 27.8 degrees. At this point, we need to solve what is being asked in the equation, in the question. First, which is the orientation of the plane of maximum in plane shearing stress. So we have a formula which is theta D is equals to theta B minus 45 degrees. Since we get the value of theta B, we need to input the values. By inputting the values, we get a theta D which is negative 17.2 degrees. That is the first orientation of the plane shearing stress. The second one is theta E is equals to theta B plus 45. At this time, we use plus 45 degrees. By inputting the theta B value and adding it into 45 degrees, we get 72.8 degrees. And that's it. That is the value of our orientation of the planes of maximum in plane shearing stress. This one, 78 and negative 72. In letter B, which is the corresponding normal stress, being asked to find the value of corresponding normal stress is equals to theta, I mean sigma average, which our normal stress is equals to 82.5 MPa. And that's all. Thank you for listening and watching.